Okay, so section 2.2, this is maximizing and minimizing quadratic functions. So your homework is what, 59, 60, and then 61 through 71 odd. So that's not a lot. What is that? 6, 7, 8 problems? I kept it to, I think, 2 types of word problems, I think. So let's see what we have. I actually wrote it out. In case you can't read my god-awful writing. Among all pairs of numbers whose difference is 8, find a pair what numbers? Whose product is as small as possible. So a minimizing problem. So what am I trying to find? A pair of numbers. And what about these pair of numbers? The difference is 8, like 1 and 9, 2 and 10, right? And they don't have to be positive, they could be negative. You know, just the difference is 8. And whose product is as small as possible. Sorry, gotta look and see what I did. Oh yeah. These are my notes. I'm gonna write it for you. Sorry. So I'm supposed to minimize my product. I'm minimizing my product of what? 2 numbers. We'll call them x times y. Because it's a product multiplication, right? So this product is minimum, as small as I possibly can, these 2 numbers. What else did you tell me about these pair of numbers? They're also what? The difference is 8. I have 2 equations. I have 2 unknowns. But this is what I'm trying to find, is a pair of numbers whose difference is 8 that is the smallest product possible. So what we're going to do is we're going to go ahead and take this one and we're going to isolate it for one of the variables. So let's go ahead and just isolate it for y. Hopefully that makes sense. I didn't show where we stuck because I don't need to. Okay? Well, I subtracted x, and then I divided everything by -1, which changes everything's signs, correct? Okay. Now I'm going to go ahead and I'm going to substitute that into this equation. Now I'm down to, well, over here at least it's one unknown. So now I want the smallest product possible. So what I'm going to do is I'm going to complete this square. There's nothing out here. What's that? 4, 16. I added 16, so what must I do here? Good. So my smallest product, it's right there. It's -16. You'll watch the pattern. I'm going to do a couple problems and you're going to see it. And one of my values, because right, isn't this, I'm sorry, positive 4. The vertex is 4, negative 16, right? So I want a minimum. Isn't this a quadratic? Right? So when I have a minimum, and you know it opens up, isn't that a minimum? So what is the minimum? It is negative 16. The product minimum happens to be negative 16. And one of those values is 4. One of those values is 4. So let's put it back up in here. Negative 16, 4, and I don't know the other value. So let's divide. There's my other pair. So let's see. So x and y. So y is negative 4, and x would be 4. Do those two have a difference of 8? Yes. You can't think of another pair when you multiply the two together that will give you a product any smaller than negative 16. The quadratic, so if it asks for a max, there better be some kind of negative here because then it's going to look like this. And what is that max? Well, it's whatever that y output is in my vertex. And one of the values will be that x value. Let's do it again. It's hard to see with this kind of problem. I'm going to change this kind of problem to something that's way easier. I'm going to do like fencing in something. Because this is still abstract, because it's still just math. Let's do something real life. So we do a real life problem. As soon as I find my notes on. Haha, in the book. So I'm going to give you this. Oh, wow. This was really for me. Wow. Yeah, I can't write. Let's see. I'll help you. I forgot I wrote these notes only for me. You have 100 yards of fencing to enclose a rectangular region or piece of property. Find the dimensions. Dimensions mean that tabletop is about a 1 by 3. So it's the length times the width. That's a dimension. This whiteboard here is probably about a 4 by 8. So that's what the word dimensions means. Find the dimensions of the rectangle that maximize the enclosed area. You would never believe that's what that said. That was one thing. Here comes the second one. What is the maximum area? Wow, that was sad. Sorry. Fence, chain link, comes in a roll, right? And then you unroll it and you just measure how many linear feet that you have. And so you have 100 yards of this fencing. God only knows why you have it, but you have it. You want to make it in a rectangle for whatever that reason is. You want to find the dimensions of this rectangle that gives you the maximum amount of area enclosed. So if I take this 100 yards and I make it a 1 yard by 100 yards, I'd have 100 square yards, right? If I made it 1 by 100, because you do length times width, right? But I want the maximum amount of area. I would love to have more than 100 square yards. So I want to find out how to take that 100 yards of fencing and put it around those 4 sides to get the maximum amount of area. I want to make, I don't know what I want to make, but something. So what am I supposed to find? Here's the big thing I need to find here, is my area, the maximum. What's the area formula? I'm going to go ahead, if you don't mind, and use, no, I'm going to go ahead and use length times width. Let's just use length times width. So once I know the length and width, I'll have that. It's a max. So is this parabola going to open up or down? Down. So it's going to open down. And so whatever this area max is, it's going to be the y output of that vertex. It's going to be the k. So let's see. What else did it tell me? So this fencing, what formula do I need for the fencing in a rectangle? It has nothing to do with area. It says find the dimensions. When I said that this is a 4 by 8, what am I talking about when I want to do the dimensions? It's called, we'll do it tomorrow.